Today we will be talking about phylogenetic classification. We will talk about phylogenetic classification. So this is a system of classification. It is a system of classification that names or classifies organisms based on evolutionary history. That is based on evolutionary history. So in this, actually, evolution, the current view of evolution is followed by the theory of Charles Darwin in 1860. So we follow it through natural selection is what forms. So there is minor changes or advancement of characters. Some people come with the passage of time in that organism. So this is what Darwin proposed. Then there is a natural selection, there is the survival of the fittest, and lots of theories along with Charles Darwin. And so phylogenetic classification, it names or classifies organisms based on evolutionary history. So linear hierarchy or classification, what it does is, it gives phylum, subphylum, class, order, it divides it like this. For example, phylum Chordata. We give a phylum. It is divided into subphylum Hemichordata, subphylum Urochordata, and it is divided into, say, subphylum Cephalochordata. So this type of classification, it takes into account, it's the natural as well as artificial. It's basically, you can call them natural classification. This type of classification takes into account attributes or characters. Takes into account attributes. After taking the attribute, it puts the it gives a hierarchy. Opore subphylum, opore phylum, niche subphylum, tactile class, it's something like that. And it gives a hierarchy based on ranks, based on taxonomic rank. So this is actually the natural or Linnaeus hierarchy, the system which we put. That you evaluate as many as attributes or characters as possible. Then, on the basis of character, you divide them into group them into hierarchy, phylum subphylum करके you are doing it, and that is based on you do this hierarchy based on taxonomic rank. Phylum is above, subphylum is below. But in phylogenetic classification, it also does the same way. It also does the same way. For example, you write chordata, you divide that into chordata. So you divide it like this. But this is not phylogenetic classification because you are not considering. This is not phylogenetic because you are not considering evolutionary history. So as for this, A is the ancestor species. It has got some characters. B and C, they get some other characters. It gets one plus one character. This gets say minus one character. One character A has got say many characters. So it gets one additional character. Say it gets power of flight, and this gets ability to live underwater, so loss of lungs, say for example. Gills develop, but A cannot live. Then B can become B over here, C can become E over here. Maybe it gains plus 2 characters, this gets plus 2 characters, some different characters. Okay. It gives to F, G. Maybe this gets plus 8 characters, plus 1 character, some different character. It gains or it may lose characters. So, this becomes a clade. This particular line becomes something known as a clade. It is an single evolutionary lineage. It goes like this. It can be like this. Eventually it is something like this. You are dividing this into 3. But what it does in evolutionary classification, you can have an ancestral species. This is giving one line, hemichordata. Second line, a different parallel evolution, you are having chordata, you are having neurochordata. Maybe cephalochordata can give later rise to vertebrata. Okay, so this type of, it is a divergent evolution. From one point, it's diverging in 3 points. Something, for example, dinosaurs, from there it comes to You can divide them into non-avian dinos, avian dinos, birds. You can divide them something like this. And this takes into account fossil records. This is an evolutionary evidence, fossil records. Clear? But where fossil records are not possible, you can take, for example, characters and say which is closer, which is not closer, which is a more advanced character, which is a less advanced character. For example, everybody knows presence of lungs is an advanced character. It allows you to live on land. So, for this type of study, for this type of character, you are using clades and drawing phylogenetic trees, cladograms. For example, let us draw a relationship. This is an ancestor species, common ancestor. From there, one group on the basis of fossils and advanced characters, you have mammalia or mammals. Then it has diverged. Maybe you have turtles, they are chelonians. Chelonia, turtles. Turtles is a part of reptiles. They are reptiles only. I am not asking, they are writing reptiles. This is the line of the reptiles. One side, you have the line of the mammals going on. On one side, you have the line of the reptiles going on. Turtles are chelonians. Then you can have lizards and snakes or lacertilians. Snakes and lizards, they are in the same group. They are known as lacertilians. Lacertilians, TE. Lacertilians. Then you have the crocodilians or the crocodiles. They diverged at this point. You may have a common ancestor. These are all common ancestors. 1, 2, 3, 4. So 1, 2, 3, 4. They are all hypothetical common ancestors. Like I have talked about cladistics, it's the same thing, that you are using cladistics to classify organisms. Crocodiles. And then there is a common ancestor, the dinosaurs may be there. From that common ancestor came up birds or apes. 1, 2, 3, 4, 5 are hypothetical common ancestors. So you have already classified this cladogram. It classifies mammals, birds, and reptiles on the basis of evolutionary relationship. Mammals, birds, reptiles on the basis of relationship. Since you people have already now studied cladistics, basic concept of cladistics, understanding is the same thing. You are using cladistics to classify. So there is one question, name one book which is using this. Currently, you can say that we are in a stage where we are unable to reject natural classification, because even in your exams, you are having to write phylum, subphylum, class, you are classifying it like this. That is, you are using the natural system of classification. We are supposed to go to the evolutionary system of classification. So modern textbooks, they are using evolutionary, this phylogenetic system of classification. For example, Invertebrate Zoology by Rupert Barnes-Fox. You can write, I have written it in WhatsApp. So the 2003 edition, 7th edition. We have it in our departmental library, but I can send you the PDF of that book. That book uses, but even still in that book, they have not been brave enough to completely reject the natural system. So they are writing the natural system also. So they are using both systems. But basically, shortly, they are explaining everything on the basis of evolutionary relationship. You can use the latest thing which they use is the ribosomal DNA sequence. They can do the classification on the basis of any DNA sequence, but the latest they are using ribosomal DNA because it's more or less conserved and it is not transcribed, so it is being used like that. So this is end of my class today, small class.